typical quadratic trinomial into a special form for graphing using a method called completing the square. This is an important method because we'll use it for all the conic sections. First, let's answer this question. What is the square that we're completing? The square is a perfect square trinomial, and the general form of it looks like this, where the coefficient of the x term is 2 times some number a. If you take that same number a and square it, that is the constant term when this is a perfect square. Let's try making a perfect square trinomial. If 18 is the 2a term, then a must be 9. And if a is 9, then the constant term needs to be 9 squared, which is 81. If you fill in 81, this factors into x plus 9 times x plus 9. And that's the perfect square when both factors are the same. So we can even write it as a square. Let's try the next one. Notice the middle term is negative. That's fine. We still look at negative 2 as 2 times some number a. So a must be negative 1. If you square negative 1, you get positive 1. And then this factors into x minus 1 squared. So that's how you create a perfect square trinomial. Let's use it in equations. Here's an equation of a parabola. First, we want to check and see if it's already a perfect square. So, if 6 is 2a, then a is 3. 3 squared is not 11, so this isn't a perfect square. Next, let's rearrange things just a bit. I'm going to scoot the 11 out of the way for now and rewrite it with a space for the constant term. All right, so since 6 is 2a, a must be 3, and 3 squared is 9. So that's the magic number we want to add. Now we can't just add a number to an equation. It makes it out of balance. So you could either add 9 to both sides, which is what we normally do, or you could do something a little different so that we can keep y by itself. We're going to subtract 9 on the same side that we added 9. So the overall result is 0 added to the equation. Now let's factor the perfect square. So x squared plus 6x plus 9 factors into x plus 3 squared. And if we combine the constant terms, that makes plus 2. Now we can see that the vertex is at negative 3, 2. And since the coefficient of the squared term is positive, it's going to open upward. So we can draw a little sketch. Here's negative 3 and 2. It is something like that. Both of these have a coefficient of x squared, so we're going to factor it out. But we're still going to keep this part separate. Even if it doesn't go evenly into that middle term, we still have to factor out the 2. It's not really the greatest common factor, it's just the coefficient of x squared. So I get x squared minus 4x, leave a space in the parentheses, and keep the 14 out here. Now, half of negative 4 is negative 2, and we square that, so we're going to add 4. Now, we can't just subtract 4 because actually that 4 is inside of parentheses that are being multiplied by 2. So the effect of adding 4 inside those parentheses is like adding 8, and we need to subtract 8 instead of 4. So we've got a 2 times x minus 2 squared, and the sum of that is 6. So our vertex is at 2, 6. And this time our coefficient is 2. It's still positive, so it opens up, but it's a little bit more narrow because it's greater than 1. So here's 2 and 6. So our vertex is here, it opens up, and it's a little more narrow. It's just a rough sketch. You could plot points if you want to be more precise. Let's try this other one. The only coefficient of x squared is negative 1, so we're going to factor negative 1 out of x squared and also the x term. Leave a space, and the 5 stays out. Let's complete the square. Half of negative 2 is negative 1. If we square that, we get positive 1. But remember, it's in parentheses being multiplied by -1, so that's really like adding a -1 to this side. So we're going to add +1 to compensate for that. And now let's finish factoring. So we've got -1 times x minus 1 squared plus 6. So our vertex is at +1, +6. And the coefficient of the squared term is negative this time, so it's going to open downward. And the width is medium because it's the absolute value of the coefficient is 1. All right, let's find it. So we're over at 1, up at 6, and it goes down and it's medium. So something like that. All right, let's try these ones. Notice in both of these, there is no x to the 1 term. If there's no x to the 1 term, we do not complete the square. It's not needed. We've already got graphing form. We just have to kind of think about what the parts are. So I've got a coefficient of -1/2. The x squared is the entire squared term. So it's like x plus 0 squared. And then we have a constant that's just out here. So the vertex is at 0, 3. And notice we have a negative coefficient, so that's going to open downward. And the absolute value of the coefficient is 1/2, which is less than 1. So it's going to be kind of a wide graph. Here's the vertex. It opens down and it's wide, so something like this. That's a nice sketch. All right, let's look at the last one. Now, it's really common to be given equations where the positive term comes first, even though it's not the x squared, but we can rearrange that. Let's put it in order of descending powers instead. So now we've got this. Since there's no x to the 1 term, we don't need to complete the square. We've already got the squared part right there. So this is like -3 times x plus 0 squared plus 7. The vertex must be at 0, 7. It opens down because the -3 is negative, and because the absolute value of that is 3, which is quite a bit bigger than 1, it's going to be narrow. So here's our vertex at 0, 7. Let's put a scale on there. Okay, and it opens down and it's narrow, so that's like something like that. All right, so there's several examples. You should be ready to do all kinds of parabolas on your homework now.